So in this video I'll be showing you how to work out the distance between two coordinates and go through some examples on how to do this along with other commonly asked questions in your textbook and in exam questions. So before we get started on working out the actual distance between two coordinates, let's just show you how the formula is actually derived. So what I'm going to do is, again, I've picked my XY axes and I've drawn a straight line, and what I'm going to do is I'm just going to pick two coordinates that lie on that line. So I'm going to pick this coordinate here and I'm going to pick this coordinate here. So this coordinate is going to have a coordinate of x1, y1, which therefore means that this x ordinate is going to be x1 and this y ordinate is going to be y1, and this point here, the second point, is going to have a coordinate of x2, y2, and again I'm going to just highlight the x ordinates and the respective y ordinate. Now from this, if I just get a different colour pen, now we want to work out the distance between these 2 points. So if I go on and draw a triangle using those 2 points and the actual line, you can see that the type of triangle it becomes is a right angle triangle. And also, as I'm trying to find the length of what the hypotenuse is in this case, which is going to be the distance between the two coordinates, I could therefore use Pythagoras. Now, in terms of Pythagoras, his theorem states that a squared plus b squared equals c squared, and in this case, this is my a, this is going to be my b, and the distance between the two coordinates is going to be c. Now what I then need to do is find out what the lengths of a and b are going to be. So if I get a different colour pen, let's go for blue. So a is going to be equal to y2 minus y1, and b is going to be equal to x2 minus x1 as a distance, and the length c we're just going to call d as for distance. So using Pythagoras, what I've then found is I'm going to have a squared, which is going to be, so d is going to be equal to, or d squared is going to be equal to y2 minus y1 squared plus b squared, which is x2 minus x1 squared, leaving us with a formula of d equals the square root. Now, just for putting it in alphabetical order, I'm going to have the x ordinates first. So I'm going to have x2 minus x1 squared plus y2 minus y1 squared. And what we've got here is the formula to work out the distance between two coordinates on a graph. And it's important that you remember this particular formula, and as it's not given to you in the formula book, but it's very easily to be derived with remembering of using Pythagoras. So let's have a look at putting this into practice with regards to some questions. So here we've got two basic examples, and what we've been asked to do is find the distance between these 2 points. So first things first, I would always say is it's always good practice for you to label your coordinates. Now again, just obviously because it's really substituting numbers into a formula, it's important that you've got the right values that you are substituting. So 3 is going to be my x1, 8 is going to be my y1, 12 is my x2, and 20 is my y2. So looking at question A, I'm going to go straight into the formula of d equals, and I'm going to have x2, which is 12, minus 3 squared plus 20 minus 8 squared. And what I'm going to do is I'm going to take my time, I'm going to simplify each of the brackets first. So I've got 12 take away 3 is 9, so I've got 9 squared plus 12 squared, all square rooted. Now remembering use of cert is the fact that I can't eliminate the square root and the powers because we're adding. If it was multiplying, I could have easily done that, but when we're adding, I'm not going to cancel square roots. I'm not going to get 9 plus 12 is basically what I'm trying to say. So we've got d equals the square root of 81 plus 144, and if I quickly use my calculator, of 81 plus 144, we get d equals the square root of 225, which lo and behold becomes 15. And then moving on to b, which I'll just do here. So 2 is my x1, minus 5 is my y1, minus 10 is my x2, and y2 is minus 6. So looking at d, and again just being extra careful with negatives, so here we're going to have minus 10 minus 2 squared plus minus 6 minus minus 5. And like I said, it's always good practice for you to write these things down and take an extra sort of care when you've got negative numbers, because again, these calculations, although it can seem quite simple, tends to go wrong, and where a lot of students make mistakes and careless mistakes is they mess up their signs. So here we've got d equals minus 10 minus 2 is 12, and 12 squared is 144, plus minus 6 minus minus 5 is going to give me minus 1, and 1 squared is 1. And so here we've got d equals the square root of 145, and I'm just going to check to see if that simplifies as a third, and it does not, so there is my final answer. Now the key thing to remember here is to check when you've made a mistake. So one, just take extra care in terms of your steps. So in, let's say, example A, you can see that I've gone through 4 steps of writing out before I've got to my final answer, which we might class as the fifth. Whereas with B, I've kind of taken a few shortcuts, I've done a bit of maths in my head, but I'm confident that this is correct. Now remember that D must always be positive. And it's kind of common sense of why that should be the case, because D is distance and you can't have negative length. So you know you're definitely going to mess up if you go straight into using a calculator and you end up with a syntax error or a math error on your calculator because you've entered some form of negative numbers incorrectly. So it's always worth taking extra care. So in this next example, we've got what we call a reverse question. So this is when we are given the answer and we need to work out what part of the question is. So in this particular question, I've got my 2 coordinates. So I've got A and I've got B. And I know that the distance is going to be, in this case, has already been told to me that the distance is going to be 5. So if I start by labeling my coordinates of x1, y1 and x2, y2, and all I've got to do is substitute the numbers in. So I've got that, well, I don't need to write D because I know what D is. So here I've got, start opening my square root, I've got x2, which is x, minus minus 3 squared, plus 1 minus 4 squared, and that all is going to equal 5. So what I'm going to do is I could get rid of the square root first because it's all being square rooted and square both sides, or I can just simplify what's in the brackets first, and that's exactly what I'm going to do first. So here I've got the square root of x plus 3 squared plus 1 minus 4 is going to be minus 3 squared. It's going to give me positive 9, and that's going to equal 5. So now at this point I'm going to expand the brackets and take the square root over to the other side. So what if I've got x plus 3 squared plus 9 equals 25. And then I'm going to end up with x squared plus 6x plus 9 plus 9 equals 25. And as you can see, this is slowly now looking like a quadratic. So here I'm going to end up with x squared plus 6x minus 7 equals 0, because 9 plus 9 is 18. 25, take away that from 18 gives me minus 7. And this does nicely factorize as x plus 7 x minus 1 equals 0. So I've got 2 values of x, which is going to be minus 7 or positive 1. Now you might ask yourself, well, how can I end up with 2 possible values? Well, the reason for that is if I just, not very neatly, draw a set of axes, and this here is my y-axis and this here is my x-axis. Now the coordinate I've been given of A is minus 3, 4, which I'm just going to take an assumption that here is where minus 3 is and minus 4 is going to be here. So I could say that this point here is where A is. Now in terms of the only information I know about B is that it's got a y ordinate of minus 1, of 1, sorry. So all I know is that B is somewhere along that line there. And I'm just going to get rid of that -4 because it should not be there. And there we go. So all I know is that coordinate of B lies somewhere along this line. And I know that it's got a distance of 5 in length away from A. Now, this could either be here. So this length here, if I just get a different colour pen just to make it a little bit more obvious. Let's go for blue because that should stand out. So that length there could be 5, in which that's where the x ordinate of -7 could come in. Or, and again this is where my diagram's a little bit bodgy, or it could be this coordinate here, which is at 1, in which both these two sides here are going to be a line of distance of 5. So as you can see, that's one of the reasons why I end up with 2 possible answers. Now in an exam, which would you give? They would usually tell you where x is positive or where x is negative. So that should give you an idea of whether to eliminate one or the other. Like I said, if it doesn't, then it's good practice for you to give both ordinates, but read out for that question, because if let's say an added part to this question where it says where x is positive, then if I gave this answer here, then I would lose a mark because I've also included a negative x value. So that's where it say x must equal, let's say 1, and there would be your final answer. But it's still good practice for you still to write down both answers, but then eliminating one for the final part of the answer. So in this example in our next example, what we've got here is another problem solving question, another proof question is that as well, simply because it says the word prove. So here it says that a triangle has vertices with coordinates of 1, 2, 13, 7 and 16, 14, and we've been asked to prove that this triangle is isosceles. Now if it is isosceles, then the key thing we need to know is that we've got 2 sides are going to be equal, so 2 sides equal, or 2 angles are going to be equal. Now it's very difficult to work out what the angles are going to be. However, for this, as this is working out distance, I'm going to tend to prove that 2 sides are going to be equal. So from this, initially what I'm going to start off with is I'm going to start by labelling these coordinates. So I'm going to call them A, B, C. And so what I'm going to do is I'm now going to work out the distance of AB. So the distance of AB is going to be 13 minus 1 squared plus 7 minus 2 squared, all square rooted, and that then becomes 144 plus 25, giving me an answer of 169, which is 13. I'm then going to work out the distance of BC, and again using the same formula, I'm going to end up with 16 minus 13 squared plus 14 minus 7 squared, which is going to give me 49 plus 49, which is going to give me the square root of 98. So far we've got 2 unequal sides, so let's see what the distance of AC is going to bring me. So here I've got the square root of 6 minus 1 squared plus 14 minus 2 squared, and that equals 25 plus 144, which equals square root of 169, which equals 13. So again, you could emphasize the fact that these 2 lengths are the same. So you could say something along the lines of same, but that's being quite brief. What I would say is, as the distance of AB is equal to distance AC, 2 lines are of equal length, therefore the triangle ABC is isosceles. And so moving on to our last example, so here we've got to prove that the triangle with vertices 2, 1, 5 minus 1 and 9, 5 is right angled. So again, what we've got to do here is show just that. Now luckily the thing is with this particular question is that our points are already labelled. I don't need to draw a graph, which is definitely strongly not recommended, although because obviously depending on your axes it could either prove that it is right angled or not. You want to prove it sort of using maths and using sort of algebra that we've learned. So for this, now in terms of proving the triangle is right angled, we could either do it one or two ways. We could either show that Pythagoras works, because Pythagoras only works with right angled triangles, or we could show that we've got two gradients are perpendicular. Now, back in the days of older A levels, you had to have showed this was probably the preferred method. However, as with regards to the new A level and looking at mark schemes, they are now allowing you to show using Pythagoras that the triangle with three coordinates mentioned is going to be right angled, and that's exactly what we're going to show. We're going to show that if it is right angled, then Pythagoras is going to work. Now, don't automatically think that with some questions, now this we've got to prove that it is right angled. Some questions might be written in a way that is the triangle PQR right angled, so it could be or it could not be, but in this we have been told that it is right angled, so Pythagoras should work. So let's start off by first of all working out the distance between each of those points. So as you can see, in terms of how I'm noting this, I'm noting this with a D, and I'm writing down what the two coordinates I'm actually looking for are going to be. So taking your time with this, we've got 5 minus 2 squared plus minus 1 squared, which gives me 3 squared, which is 9, minus 1 is minus 2, minus 2 squared is 4, giving me an answer of root 13. So then dealing with PQR, we've got 9 minus 5 squared plus 5 minus 1 squared. So 9 minus 5 squared is 4, and 4 squared is 16. 5 minus 1 is 6, and 6 squared is 36, giving me an answer of root 52. And finally, we've got to work out the distance between PR, in which I've got the square root of 9 minus 2 squared plus, and I'm going to end up with 5 minus 1 squared, which equals 9 minus 2 is 7, 7 squared is 49, plus 5 take away 1 is 4, squared is 16, giving me an answer of 65. And there we go. Now, from this, now to prove which one is going to give me the longest side, I know that this is going to be C, because this is going to give me the longest side. So that's got to be C. I'm going to call this A, and I'm going to call this B. So from this, what we've got is we've got A squared. So if right angled, so I'm actually identifying how I'm going to prove what they're asking me to prove. So if right angled, then A squared plus B squared equals C squared. So here I've got root 13 squared plus root 52 squared equals. So here I've got root 13 squared is 13, and root 52 squared is 52. And so that then gives me 65, which then gives me root 65. So C squared equals that, and therefore C equals 65. And as you can see, that both this and this are the same, and so therefore it is right angled. So as Pythagoras works, or in other words, what I'd probably say, but a better way of doing that would be to say that as dpq squared plus dqr squared equals dpr squared, then triangle PQR is right angled. And so with proof questions, it's always worth writing down these types of statements just to finish off your answer rather than just treating the fact that whoever's marking your paper knows exactly what you've done to prove it, because all you've done is you've there just showed that two numbers are the same. So it's always worth writing that extra statement, writing that extra sentence, just to put the icing on the cake, as they would say. So hopefully working out the distance between 2 points makes sense, and how we derive the formula, and also going through these types of questions, which are very, very popular when it comes to textbooks or exam questions, particularly circled around coordinate geometry, makes sense to you. And if you have any problems or would like any more practice questions, feel free to drop me an email at 162maths@gmail.com.